Hi, my name's Chris Thomas, and welcome to the third DVD in our Modeling Fundamentals series. In the first DVD in the series, we looked at how we could effectively navigate within 3ds Max so that we can manipulate our models and maneuver freely around in the 3D world. We also learned about a number of key topics such as coordinate systems and pivots, and we also learned how we could create basic model elements using primitives and then how we could actually modify those primitives using a combination of tools such as the modifiers and space warps. We also made a start on our go-kart project, building some of the axles and steering mechanisms using some primitives and modifiers. In DVD 2, we moved on to learn more about mesh editing and modeling in some depth. We looked at the key elements that make up edit meshes and edit polygons. We learned how to join meshes together and also break them apart once more. We also learned how to create faces from vertices and how to carry out some simple polymodeling operations. We also continued our go-kart modeling project by creating the kart's frame using polymodeling techniques such as edge connection, extrusions, beveling, and so on. This understanding of what polygons are, how to use primitives, and some basic polymodeling methodology are base level skills. And these will stand you in good stead for all kinds of modeling, organic modeling, architectural modeling, and mechanical modeling alike. And of course, it will help you to understand what we're about to tackle in this DVD. In this DVD, we're going to move on to look at quite a different class of geometric primitives, and these are known as curves and parametric surfaces. Their name gives the game away straight away, I would say. What we're looking at here is a set of objects that allow us to create mathematically defined curves and then to use those curves to define mathematically defined surfaces. These curves can be hand drawn and then they can be edited into a form that we need, or they can be created from some kind of simple but useful template to save time. If you're a scripter, you can even create curves using scripts. So, for instance, you can have particles create curves as they travel through a scene, or you can create curves under other circumstances. So, you've got a lot of freedom in how you actually create the curves in the first place. With templates, curves can be very quickly created in primitive shapes such as circles, rectangles, stars, n-gon spirals, and also even text. So it's very easy to create shapes that you can then take on to produce three-dimensional text objects, which is kind of great for the ubiquitous 3D logo. On their own, these curves would be pretty pointless. Not totally pointless because you can use them for things other than modeling. For instance, you can use them for animation. And we'll be looking at that very, very briefly in this DVD. The beauty of curves is that they can be combined with other curves via various tools and modifiers to define quite complex 3D surfaces. Some of these tools are relatively straightforward and will not require much thought to get your head around. Others are much more complex though, but of course with that complexity also comes power and extra flexibility. Generally, curve-based models are better suited for mechanical and architectural modeling. This comes from the mathematical nature of the curves that we create. They were designed from the ground up to represent smooth, curved surfaces, things like the hull of a yacht or a car's bodywork. And you can also create lines, and for that reason, it's a great way to actually work and produce architectural models. So they are generally, suited for producing mechanical or architectural models, but they can be used for any kind of modeling, really. They can be used as the basis for any kind of model that you can think of, or that they're suitable for. Indeed, many in the CG industry today undervalue curve-based modeling as there's such a general focus placed on character modeling. This is seen as kind of, as it were, the epitome of modeling. But that particular topic is best tackled with sub-Ds, which is a subclass of polymodeling. We'll be looking at that in DVD 4 in this series. But this inability to create organic models isn't really a weakness of curves and lines, though, the spline-based tools. Instead, it's a strength. When you need to model any mechanical, technical, or architectural objects, you'll find that curve-based modeling is generally the way to go in the vast majority of cases. In the other cases, you'll find that you'll be able to use primitives or you'll be able to do some polymodeling, and that's why this series covers every area of modeling in 3ds Max that I feel is actually used these days in the industry. So that's what we'll be looking at in this DVD. We'll be looking at curves and how we can use those curves with the spline-based tools in 3ds Max to make 3D surfaces. Let's have a quick run through of all of the topics that we're going to look at, chapter by chapter, before we make a start on chapter 1. So in the first chapter, we're going to look at the history of the Bezier curve. I think it's important that before we go on and we start talking about how we're going to use Bezier splines in various modeling systems and tools, that we actually understand where the Bezier spline was developed from. So in chapter 1, we'll briefly look in at that subject and see where it all began. In chapter 2, we continue our exploration of the earlier days of the Bezier spline and also Bezier spline fundamentals. I mean, what is a Bezier spline? How do we make a Bezier spline? What are the fundamental elements of it? Then in chapter 3, we'll be continuing again by looking at some of the basic templates that you'll have to build your Bezier splines out of. Things like the rectangle, the circle, the helix, the star, and so on and so forth. And I'll just quickly run through how you can create those and the various parameters that allow you to control those various template spline objects. Then in chapter 4, we'll look at how we can take these curves. After all, up until this point, we've been talking about mathematical curves through space, but when it comes to actually modeling and rendering these surfaces, we need to have them represented by polygons. And for that to happen, we need to go through a process of tessellation and also of interpolation. So here we'll be looking at how we actually interpolate from one control point on a spline to another control point, and then how we can use that interpolation to define our tessellation of our final mesh. And then in chapter 5, we'll be looking at some more fundamental elements of modeling with splines. And this is basically a series of practical tips, things that you should do when you're modeling with splines, things that you shouldn't do, how to break your splines apart, how to attach them together again, how to actually cut entire shapes out of other shapes, and so on and so forth. And then in chapter 6, we'll be doing an overview of the basic idea behind curve-based modeling, how we can combine multiple curves together to produce surfaces. In some of the tools, we'll only need one curve. Other tools, we'll need 2, 3, 4, 5, 6, whatever. So we'll just basically be looking at how curve-based modeling works in this chapter. And then in the next section of the DVD, we'll be looking at 3 of the main spline tools in 3ds Max. We're not going to look at every single spline-based tool in this particular DVD. There just isn't time to do that. But what I am going to concentrate on are the 3, well, what I consider anyway to be the 3 main spline-based modeling tools in 3ds Max. And those are the extrude modifier, which we'll be looking at in chapter 7. This allows you to take a single spline and produce a shape from it by moving it along a single axis. It's quite a simple operation, but it's very useful in a number of circumstances. So it's one of those basic modeling tools in 3ds Max that really everybody should know. And then in chapter 8, we'll be looking at the lathe modifier, which basically does the same kind of thing really as the extrude, but instead of going around moving the shape through space along a straight line, it actually rotates it around a certain axis, and that then gives you a cylindrical surface. So if you know what a lathe is and you know what lathes are used to produce, then you'll understand exactly what the lathe modifier does. And then in chapter 9, 10, and 11, we'll be looking at the loft compound object. And the reason why I've broken up this particular tool into 3 separate chapters is because it's actually relatively complex. It has quite a large number of options and it's very flexible in how it can be used. But at the same time, don't be scared off by that, that complexity, because it really makes it a very, very powerful tool. And you can do a lot of things with a loft object that you can't really do with either lathe or with the extrude modifier, or indeed any other modeling tool in 3ds Max. And it's one of the real gems in 3ds Max's arsenal. So it's well worth learning how to use the loft tool. Because even if you're really going to concentrate in your career on polymodeling, pure polymodeling or sub-D modeling, every now and again you'll come to the point where it just makes much more sense to model something using a loft and then to convert it into a poly object later on. And if you want to adjust that object later, you could always go back to the original loft object, make a slight modification there, and then convert it back into a poly object again to include in the rest of your basic poly model. So don't discount any of the spline-based tools that you see in this particular DVD. They can be used with anything, because at the end of the day, the surface that these spline-based tools produce is a mesh and can be converted into either an editable mesh or an editable poly, and can be worked on further using those tool sets. So these 3 tools, the extrude, lathe, and loft, are very, very useful for everybody, basically, that uses 3ds Max. And then, again, in the next 3 chapters, we return to the modeling project that we started in DVD 1 in this series and continued in DVD 2. And in this DVD, we'll be looking at adding elements to that model which are based on the spline-based tools. So we'll be adding things like the wheels, where we use a lathe. And we'll be adding a sort of a finesse to the actual steering column of the go-kart, a sort of mounting section on top of the steering column, and that will be produced using an extrude. And we'll be producing wires that go down, little sort of wire cables that go down the side of the go-kart to control the brakes. And for that, we'll be using the loft object. We'll be using, as I said, a combination of the spline-based tools that we've looked at in this DVD to enhance the go-kart model. So in chapter 12, we'll be working on the steering column. 13, we'll be working on the steering wheel itself. And then in chapter 14, we'll be modeling the wheels and the tires. And then in chapter 15, we'll finish off this DVD by taking a slight detour and looking at how splines are used in 3ds Max through various areas of the animation system. We'll see how you can modify the animation of an object in the function curve editor. We won't be working with that in depth, but I'll actually show you that splines are involved there. I'll show you that you can actually animate your paths, the paths which were used in the loft object, which is something you'll come to later in this DVD, obviously. How we can change the shapes which make up those lofts. We can animate all of those things. And we can animate parameters of some of these tools as well. I'll show you how you can animate some of the parameters in the loft tool to produce different special effects. So it basically shows you that splines are, they're omnipresent really in 3ds Max. They're used in so many different areas. And as I said, they feature massively in the animation system. So as you can see, we've got a massive amount of stuff to cover in this DVD as per usual. So let's make a start in chapter 1 by looking at the history of Bezier splines.